Hello everyone. Next we have to solve a problem with constraints. Okay, with the reactive power constraints. So this is our second problem on fast decoupled load flow analysis. Again, how will we do it? Now I am going to summarize the steps again. So what we will do, first we have to find out the Y bus of the system and we have to convert it into the polar form, and next what we have to do is we have to find out all the details regarding the bus data, and we have to classify the buses into slack bus, PV bus and PQ bus. In the third step we have to find out delta P, delta Q. In other words, we have to find delta P for all the buses except our slack bus and delta Q for all the PQ buses. In this case, even though in bus 3 we have power and the voltage, that is even though bus 3 is a PV bus, but we were given the reactive power constraints, which means that we have to find out the QI calculated or Q3 calculated, and if my Q3 calculated value is within the limits, then I can say my bus is a PV bus. Else if the limit is violated, then we have to convert this bus to a PQ bus. Okay, then at that time we have to find out delta Q3 also, otherwise we don't have to find out delta Q3. So that was our third step. In the fourth step, after finalizing the type of bus, we will find out the susceptance matrices B dash and B double dash. B dash is the susceptance matrix for all the buses except slack bus, and B double dash is the susceptance matrix for PQ buses alone. And in the next step what we are doing is we are updating the values of delta. So we have to find out delta and delta E. Delta is equal to minus of B dash inverse of delta P by delta E, and delta V or delta E is equal to minus B double dash inverse of delta Q by delta E or delta V. Like that we will find out delta and delta V values, and in the next step we update the delta value and V value, that is we update the voltage parameters for the next iteration, that is delta K plus 1 is equal to delta K plus delta K. Okay, and like that we will update, and next we have to continue with our step 3. We have to find out PI calculated, QI calculated, then we have to find out delta P and delta Q, and we have to assume, and if the power mismatch is for the consecutive iterations is less than 10 raised to minus 3, then we can stop our iterations. Okay, this is the method. First we have to do it. So I am going to write my, or I am going to find out my Y bus. Okay, finding out my Y bus, I am checking my transmission line parameters plus J terms are coming, which means that it is a impedance term. Line impedance is given. So we have to construct the table. Okay, I have filled the line impedance data with my table. Within the table, that is 0.18, isn't it? Say 0.18 plus 0.22 I inverse. Like that I have to fill my values. Okay, and I have to fill my values, and I have to write the complete the table. Okay, so I hope you understood what I am saying or what I am doing, because it is very easy for us to do it. So again, the last time I am again showing you 0.18 plus 0.22 I inverse. That value will be equal to 2.227 and minus 2.7228. Okay, so I am writing this, that is minus 2.2277. I'm sorry, this is plus. Okay, plus 2.2277 minus J 2.7227. Okay, so like that we have to find out the remaining values. So I have found out my values for this inverse. So this is the z value and this is the y value, that is equal to 1 by z. Okay, so what is this? This is my y12 value, this is equal to y23 value, and this is equal to y13 value, and we are having our y bus, and our y bus is a 3 by 3 matrix. So y11, y12, y13, y21, y22, y23, y31, y32, y33. This is the admittance matrix we are having here. From this we can say y11 is equal to y12 plus y13, and y12 is equal to y21 is equal to minus y12 value, that is equal to minus minus 2.2277 plus j 2.7227, and y13 is equal to y31 is equal to minus y13 value, that is equal to minus 1.6014 plus j 0.5433. So similarly I will complete my entire y bus. Okay, so I have filled my y bus matrix. I have filled my y bus matrix, and it is y11 I have found out, and y12 and y21 are same, that is minus of y12, the minus of this, and this is y13, so minus of the same value I have written, and then I have converted this rectangular form into the polar form. Okay, so now we have our y bus in rectangular coordinate system and also in polar coordinate system, and this is not in degrees, I have calculated in the radian mode. So I have completed my step 1. What is my step 2? We have to find out the type of bus. What are the type of bus we are having? So step 2 is I have to calculate the bus data. Okay, so I am forming the table, that is bus data. I have written the table, that is bus number, generation, load, voltage and type. So for our first bus we were given the value only, voltage value only, so that is 1.05 and angle 0 it is given, so we can write it as a slack bus. And in the second bus they have given 650. Oh, you can't see this. So in the second bus they have given 650 and 530 MVAR. Okay, so here I am converting it into my per unit. So I am taking my SP base value as 100. Okay, so how will I write? This is load, no? So I have to fill it under PL and QL. So it will be 6.5 and 5.3. So PL and QL is 6.5 and 5.3. No other values are given. So this is a PQ bus, and I have to assume the value as of voltage as 1 plus J0. Okay, so I have to assume the value of voltage as 1 plus J0. And next is my third bus. In the third bus they have given power and voltage value. So what is the voltage value they have given? It is 1.03. So it is 1.03, and power is generated power. So it is 480. 480 divided by 100, that is 4.8. And they have given the reactive power limit. So I am just adding my reactive power limit here. So this is MVAR, that is in per unit value they have given. So this is a given constraint. So here P value and V value is given. Here P value and V value is given. So this is a PV bus, and if this is a PV bus, if the Q limit is satisfied, if the Q limit is satisfied, then it is a PV bus, and if the Q limit is violated, else it will be a PQ bus, else this will be a PQ bus. Okay, so we have completed our step 2 also, and next what we have to find out is we have to find out our delta P and delta Q values. Okay, so in the step 3 I am adding paper. Step 3, I have to find out delta P values and delta Q values. When I is equal to 1, we don't have to find it out because it is a slack bus. When I is equal to 2, here my iteration, first iteration I am going on, my I is equal to 2, then my second bus is a PQ bus as per our requirements given. It is a PQ bus, so we have to find out delta P2 and delta Q2. What is delta P2? Delta P2 is equal to P2 scheduled minus P2 calculated. So that is equal to P2 generated minus P2 load minus P2 calculated. What is equation for PI calculated? PI calculated is equal to sigma n is equal to 1 to n VI YIN VN cos theta in plus delta n minus delta I. This is the equation. So in order to find out P2 calculated, here I will become, okay, 2, I am writing it directly, that is V2 into, I am just taking 2 common, V2 into Y21 V1 cos theta 21, because delta 1 and delta 2, all the delta values I am assumed it as 0 for the first case. Okay, theta 21 plus y22 v2 into cos theta 22 plus y23 v3 into cos theta 23. So this is our equation for P2 calculated. So I am substituting my V2 value. No value is given, so I am taking it as 1 no. So then what is Y21? Y21 is 3.5179 into 1.05 into cos of theta 21. What is theta 21? 2.2565 plus what is y22? Y22 is 4.4972 into V2 value is again 1 into cos theta 22, that is minus 0.8525 plus what is y23? Y23 is 0.9878. V3 value is 1.03 into cos theta 23 value is 2.4051. Okay, so this is the value for P2 calculated, and if I am doing my P2 calculated, that is 3.5179 into 1.05 into cos 2.2565 plus 4.4972 cos 0.8525 plus 9878 into 1.03 cos 2.4051. So that value I will get it as my P2 calculated value will be something like 0. So the value I got it is 0.1331, okay, per unit. That is my P2 calculated value was minus 0.1331 per unit. Okay, so that is 3.159 into 1.05 into cos 2. Like that, same I have written within the brackets. No need of any confusion. So I have done it and I have equated it and I got it as minus 0.1331 per unit. So my P2 calculated value is 0.1331 per unit. Then what I have to find out? I have to find out my delta P2. Delta P2 is, what is my P2 generated value? Is there any generator value? No generator value is there. So minus, what is my load value? That is 6.5. 6.5 minus is 0.1331. Okay, so that is plus 6.5 I am doing. So what is it? 6.3668. 6.3668. Okay, so that is equal to minus 6.3668 per unit. This is my delta P2 value. Similarly, I have to find out my delta Q2 value. What is delta Q2 value? You know, delta Q2 is Q2 scheduled minus Q2 calculated. So what is the equation for QI calculated? QI calculated is equal to minus of sigma n is equal to 1 to n VI YIN VN sin theta in plus delta n minus delta I. So what is QI calculated? Okay, this is the equation for QI calculated. So Q2 calculated will be equal to minus of, what is VI? I am taking it as common. Here it is Q2, no? So V2, because V2 value is 1, no? I can neglect it. That's why I am taking it as common. V2 Y21 V1 sin theta 21 plus y22 sin theta 22. V2 is also there. V2 y22 sin theta 22 plus y23 v3 sin theta 23 value. This thing I have to do it and I have to find out our value. Okay, so the same equation only we have, so I have to substitute it. So that is, what is y21 is 3.5179 into 1.05 into sine of 2.2565 plus V2 value is 1, then y22 is 4.4972 sine of minus 0.8525 plus 0.9878 into 1.03 into sine of 2.4051. Okay, so this is the value we have to find out. That is 3.51 into 1.05 into, instead of cos I am putting sine 4.49 into, instead of cos I am putting sine, and again in one more portion we have to put cos, it is sine. So I am putting the sine value, and what is my value? It is 0.156. okay, so I have to get my Q2 calculated is, that is equal to minus value is also there, 0.1562. 0.1562 per unit. Okay, so this is my Q2 calculated value, and next I have to find out my delta Q2. Delta Q2 is equal to Q2 scheduled or Q2G minus Q2 load minus Q2 calculated. That is equal to, what is Q2G? There is no Q generator, but the load is there. What is the load value? Q2G is 5.3, isn't it? So that is minus 5.3 minus is plus, no, 0.1562 per unit. Okay, so that is equal to, here it is minus 5.3. What is the value? That is minus 5.1438. that is minus 5.14. Delta Q2 is minus 5.1438 per unit. Okay, so this is my delta Q2. And next what we have to find out? We have to find out for my bus 3. My bus 3 is a PV bus, but the Q limit is given. First anyway we have to find out delta P3. That delta P3 is equal to P3 scheduled minus P3 calculated. No, so next I am going to find out my P3 calculated. P3 calculated is equal to V3. I am taking it outside common. That is Y31 V1 cos theta 31 plus Y32 V2 cos theta 32 this delta values are all 0. That's why I'm writing it like that. Okay, otherwise I will write the entire thing or you will get confused. Why teacher is writing in one form in one case and other form in another case. So no need of getting any confusion. I am writing it again. Okay, cos theta 3 3 here 3 1 plus delta 1 minus delta 3 was there. Okay, so if I am substituting my v3 value, what is my v3 value? V3 value, it is already given as 1.03, isn't it? 1.03. So I am writing it as 1.03 into what is y31 value? Y31 value we have to get. So y31 value is 1.691. So y31 value 1.691 into v1 is 1.05, isn't it? v1 value is 1.05 into cos of what is the angle? That is 2.8145 plus y32 is 0.9878 into v2 value is 1 into cos theta 32 is 2.4051 plus y33. What is y33 value? Y33 value is 2.6268 into v3 value is 1.03 into cos theta cos of minus 0.4773. This is the equation we have to find out. So we are going on to find out our equation, that is 1.691 into 1.05 in 1.05 cos 2.8145 plus 0.9878 cos 2.4051 plus 2.6268 into 1.03 cos minus 0.4773. That value will be equal to, oh, that is a very low value I am getting for delta P3. So some value into 1.03. That value delta P3, sorry, not delta P3. P3 calculated I am getting as 0.010 like that, minus 0.0, that is minus 0.010 103 I can write it as. This is my P3 value. Okay, so I will check whether the value is same. Next, what we have to find out is we have to find out our delta P3 value, isn't it? So delta P3 value we have to find out, that is delta P3 is equal to P3 generated minus P3 load minus P3 calculated. That is equal to P3 generated is 4.8 minus 0 minus our value was 0.0103. Okay, so our value was minus 0.0103. So our value is plus 0.0103, that is 4.8103 per unit. This is the equation for our delta P3. And since even though it is a PV bus, but we have to find out QI calculated value or Q3 calculated value we have to find out. What is Q3 calculated value? That is minus of V3 into Y31 V1 sin theta 31 plus delta 1 minus delta 3 plus V3 Y32 V2 cos theta 3, sorry, it is not cos, it is sin theta 32 plus delta 2 minus delta 3 plus V3 into Y33 into sin theta 33. This is the equation we are going to do. Solve. That is equal to minus of what is V3 value 1.03 into what is Y31 value. Y31 value is 1.691 into 1.05 into sine of 2. See once more, that is equal to minus of 1.03 into 1.691 into 1.05 into sine of what is theta, sine theta 31, no, that is sine of 2.8145, 2.8145, all others are 0, plus y32 value is 0.9878 into v2 value is 1 into sine theta 32 value is 2.4051 plus v3 is 1.03 into y33 value is 2.6268 into sine of minus 0.4773 value. So this is the equation we are going to solve it. Okay, so what will I do is I am going to find out the Q3 calculator, no. So what I will do, I am directly substituting it. I am changing my values into sine. Okay, so this 1.05 cos is sine 2.815 into 0.9878. Here also cos value, it is sine. This is very easy because we can save our time. We all know we don't have much time for our exam if questions like this come, so it is better we use some technique. So the value if for Q2 is very less, oh my god, it is very less, that is equal to minus 9.208 into 10 raised to minus 3 per unit, or if I am writing it, it is minus 0.009. Okay, or which is much lesser than our limit. What was our limit given? The limit given was it is 0.1 less than Q3 less than 1. Okay, but this value is much lesser than this 0.01, so Q limit is violated. Okay, so our Q limit is violated and our bus 3 is converted to a PQ bus now. So in order to find out delta, then we have to find out delta Q3. Delta Q3 is equal to Q3 scheduled minus Q3 calculated. So this Q3 scheduled we will take it as lower limit because it is very near to the lower limit. So Q3 scheduled is 0.1 minus this value. 0 minus means it is plus only, isn't it? So that is plus 0.9 0.009 something, no? So it will be 0. Wait a minute. Q3 I have to take a minus here, minus, and then it will become plus, so it will be minus again. So what will I do? Let us 0.1 minus 9.208 into 10 raised to minus 3. That is equal to 0.0908 per unit. So my delta Q3 value is 0.0908 per unit. So we have completed up to our step 3. Next, what will we have to do is we have to find out in next we have completed our step 3. Next is our step 4. Now we know our system has only Thus, one slack bus and two PQ buses. So next we have to find out our B dash matrix. Okay, so B dash matrix is since we have no PV buses here our B dash and B double dash values will be always same. Okay, because no PV bus are there, only PQ bus are there. No, so B dash is equal to B double dash is equal to I am writing. So first I have to remove first column and first row, so it will be minus 3.3862 and 0.6635, 0.6635 and minus 1.2068. so this is the equation, this is the matrix I got for my B dash. So what will be my value for B dash inverse? B dash inverse will be mode, I am putting it into matrix 2 shift mat dimensioning first matrix 2 equal to A11 is minus 3.3862 minus 3.3862, then is 0.6635 and 2 is minus 1.2068. This is my matrix. So shift mat 3 1 matrix inverse, isn't it? So my matrix inverse will be equal to 0. That is equal to minus 0.3309, then minus 0.1819, then minus 0.9286 and minus 0.1819. okay, so this is my B inverse matrix. How I have found out my step 4, and in the step 5 what we are going to find out is we are going to find our delta equation. What is delta equation? Is equal to minus of B dash inverse into delta P by delta E, or here we are using V term, no? So delta P by V, this is the equation. Okay, so what is the delta matrix I have got here? What are the matrices I have got for delta 2 matrix? So I have delta 2 and delta 3. okay, this I have to find out. This is our first iteration value. Okay, that is equal to minus of B dash inverse into, how will I find out? That is delta P2 by V2 and delta P3 by P3. This thing we have to find out. That is equal to minus of B dash inverse into delta P2 value we have to take. What is delta P2 value? That delta P2 value is here only, minus 6.3668. okay, that is minus 6.3668 divided by V2 value is 1 itself. And what is delta P3 value? That delta P3 value is, here we have found out, no, 4.8103. 4.8103 divided by 1.03. so this is the matrix I am going to get. So again I am finding out another matrix, that is shift mat. I am dimensioning second matrix, B matrix to shift mat 1 2 dimensioning, that is 2 rows and 1 column, like that. B11 is minus 6.3668 and B21 is 4.8103 divided by 1.03, that is okay. And I am doing it shift mat 3 answer, matrix answer into shift mat 3 and my matrix, that is this answer into matrix B. I will get the value as, this is also a 2 by 2 matrix, no? So I am taking my paper, another paper. So that will be equal to delta 2 of first iteration will be equal to 1.2574 minus 1.2574 delta 2 value, and what is the next value, that is minus 3.178. So delta 3 of first iteration is equal to 3.1785. Okay, so these are the two values we got while considering our delta 2 and the delta 3 value. Okay, next what we have to find out is, we have to find out our delta V values. Okay, in order to find delta V, that is minus B dash inverse of delta Q by V, isn't it? So here also there is two term, delta V2, delta V3. How will we find out? That is equal to minus of B dash inverse matrix, same matrix, 0.3309 minus 0.1819 minus 0.1819 minus 0.9286. This matrix into delta Q2. What is delta Q2 value? What is delta Q2 value? We have to find out. Delta Q2 is minus 5.1438, minus 5.1438, and V2 value is 1 itself. And what is delta Q3 value? Delta Q3 value, we found it as delta Q3 value, it is 0.0908 divided by 1.03, isn't it? It is 1.03, and we have to find the answer. Okay, so again shift math 1 that is 2 by 2 that is minus I am taking outside inside, so 0.3309 0.1819 0.1819 0.9286, and then shift math dimensioning second matrix 2:1, that is equal to minus 5.1438, and the other one is 0.0908 divided by 1.03. Okay, then shift mat 3 first matrix into shift mat 3 second matrix 2. That value I got it as delta V2 is minus 1.81, delta E2 is equal to, that is equal to minus 1.686, and the second value is minus 0.8537, minus 0.8537. These are the values I got for my 1.868. Okay, these are the two matrix values I got for as my delta E value. Okay, next what I have to do is, I have to find out my then we have to find out our next iteration values. We have to advance the step 6. What is step 6? We have to find out the delta. Okay, so delta k plus 1 is equal to delta k plus delta k, isn't it? So we have to find out delta 2 is equal to delta 2 for second iteration is equal to delta 2 of 1 plus delta 2 of 1, that is delta 2 of 1 is 0 plus delta 2, we have to do it. Okay. So delta 2 of 1 is 0 plus delta 2 is minus 1.2574 is the next value, and delta 3 for the second iteration is equal to delta 3 of the first iteration value plus delta 3 of the first iteration, that is delta 3 of first iteration. This is 0 plus that is 3.1785 is the value. Next we have to find out V2 for the next second iteration is equal to V2 for the first iteration plus delta V2 for the first iteration, that is equal to V2 for first iteration is it was 1 plus delta V2 is minus 1.686, that is equal to minus 0.686 is the value for next iteration. And what is the value for V3? V3 for second iteration is equal to V3 for the first iteration plus delta V3 value, that is equal to V3 for the first iteration it was 1.03, isn't it? The value is 1.03. So 1.03 plus minus 0.8537. So that is equal to 1.03 minus 0.8537. That value is equal to 0.1763. Okay. So that value will be equal to 0.1763. So this is the value for third iteration of second iteration of the voltage. Okay. Next we have to continue the same, and we have to proceed until the power mismatch values are equal to power mismatch values for the consecutive iterations is less than or equal to epsilon or 10 raised to minus 3. I hope you understood the problem, and next we will proceed with our next portions. Okay, so if there is any doubt, please ask me. Submit your problem in your Google Classroom within the due date. And thank you and happy learning.